Okay, so today we're going to start Unit 6, and I'm starting on Lesson 6.2 instead of 6.1 because, for one thing, it lines up with the book, and I know that that makes things easier for you. And for another thing, I kind of like to look at what we've been doing for the last several days as 6.1. So this is 6.2, applying right triangles. A lot of this is going to be review using the things that we've already done. So, or things that you've learned in geometry. I'm going to go over a couple of concepts. So the very first thing we want to talk about are the triangle sum theorem, which says that if I add up the sum, I'm going to talk about these in a minute, but if I add up the sum of all the angles in a triangle, it's 180. That's a super important concept we'll be using today. So just a reminder of that. Also Pythagorean theorems, a squared plus b squared equals c squared. So again, another concept that we may use. Here's the thing, is that you will need to kind of look at each problem individually and decide, okay, what might I use to solve this problem? Okay, reminder on your special triangles. We've learned these the last couple of days. But just a reminder on those, you'll use those today. We'll also use SOHCAHTOA. Okay, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So these concepts I know you know pretty well. We have your quiz grades were really fantastic, so I hope you still remember all of these things. So going right into example 1, okay, we need to be able to solve triangles or solve pieces of triangles. Now, this one, there's actually two different ways to solve it, and I'm going to show you the hard way first and then the easy way. So the hard way is to use, we know that, first of all, we need to use the 180 degree rule to say we know this is 90 and 45, so this one has to be 45. I wrote this 12 here. Technically, we don't know that, but since it's a 45, 49 triangle, you do know that this is 12. Well, and that's going to be important knowledge. Since these are the exact same angles, these lengths are the same. So 12 squared plus 12 squared equals c squared, which is 144 plus 144. And this gets a little tedious. This isn't really difficult, but if you do it this way, the work is long. You can do this problem with absolutely no work at all, and I'll show you in just a minute. So we take the square root of 288, which is 2 times, sorry, I messed this up the first time. It's 12 times the square root of 2. I'll erase it and go back and do it again. So it's 12 square root 2 is c. Now, the other way to know this, okay, if you know your 45, 45, 90, okay, we know this is 12 and this is 12. If you think about the idea of proportions, that this one is 1 and this one is 1, and this one was square root of 2, then I could say this is 12 times the square root of 2. Oops, back up a little bit. So it's just nice to know that you could do this. If I have triangles that are like this, I can do them without having to do all of this work. And on the practice problem, I'm actually going to do that. When you have proportions here, you can use them proportionally. So here's your practice 1. Go ahead and do the problem, and then I'll explain. So keep in mind this is a 60, 90, and we know what that is, so it's 30. Okay, triangle. So use your what you know about those. Okay, the solution, just coming in just a second. There we go. Okay. So to work this problem out, if I know this is a 60, 30, 90 triangle, I know that with a 60, 30, 90 triangle, I have this right here. I'm going to draw it right here. This is 1, square root of 3, and 2. So proportionally, this piece right here is half of this piece. So I'm going to divide 20 by 2 and know that this is now 10. And then this is going to be 10 times the square root of 3. And that's it. That's all you have to do. Otherwise, I could use Pythagorean theorem, but I don't need to. Okay, this situation, you're going to be given problems like this where you have to give me all the pieces of a triangle. It will be a right triangle. You draw it yourself. Okay, you'll have A, B, and C. B is always the middle angle. Okay, so and the little a's and the little b's are always I messed those up. Sorry. They're always the one directly across from the angle. So your A's go together, your B's go together, and your C's go together. So as far as little and big, it really doesn't matter. Usually the little one is the side, not the angle. So in this case, I know that 4.2 is A, and I know that C is 33 degrees. I need to find A by going 180 minus 57. Never mind. This is again where I screwed up and erased. I apologize for not being able to fix this on the fly. I don't know how to edit videos. I've tried a couple of times, and they take me way too long for it to be worth my time. So anyway, 180 minus 90 minus 33 is 57. So I have all my angles. Now, this is where you need to go back to your sine, your SOHCAHTOA. All right, the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, so that I can solve for these lengths, okay? So we're going to, and it really doesn't matter which ones you use. Some are easier to use than others, and I don't necessarily, in the example, use the easiest one, all right? I just want to show you it will work no matter what I do. Calculators are absolutely important here. Please make sure that your calculator is in degree mode when we're dealing with degrees. If you have it in radian mode, it will mess up the problem. So calculator's in degree mode. So I'm going to set it up with, I need to use this, I could use either this angle or that angle, but I need to use this side so that I have 3 out of the 4 pieces. So I'm going to use the sine. Sine is opposite over hypotenuse. So I'm going to go the sine of 57, because I know this. What I want is I want 2 of these 3 pieces. If I have 2 of these 3 pieces, then I can solve for the third one. Is 4.2 over b. So then I can now solve this algebraically by multiplying both sides by b. And if you know an easier way to do this, you don't have to go through all the work. But I do need to see this step for sure. So b times sine 57 equals 4.2. Then I divide by sine of 57. And I get b equals 5. Now, I have all the pieces except for C. So now I have to go solve for C. So in any of these, I have to solve, I need to know what A, B, and C are the angle-wise, and I also need to know what A, B, and C are sidewise. So if you're given this type of a problem, you have to solve for all 6 pieces. Usually you'll be given 2 to 3. So I'm going to use the tangent now. The tangent of 57 equals 4.2 over C. And I will solve for C, just like I did B in the last problem. So C tangent of 57 equals 4.2. Divide by tangent of 57, and I get C equals 2.7. I have to tell you, the first time I did this problem, I forgot to put my calculator in radian mode, and I had all kinds of weird answers. I mean, I forgot to put it in degree mode. So make sure your calculator is in degree mode. All right, practice problem. Same idea, except for this time you're given little c and big C. So go ahead and pause the video, do the problem, and I'll go over the solution in just a moment. So here's your solution. So we're going to draw our triangle, make sure that we have all of the pieces. So I have C is 28, and then directly opposite of C is 4. I use my 180 minus 90 minus 28 to get my third angle. That's always the first step. Go for the third angle first. So that is 62. I just put that in my calculator. Now I'm going to use cosine. It really doesn't matter what I use, but cosine is 4.4 over, where did I put C? I have C. It really doesn't matter what this letter is. It's just, this is the one I'm looking for as a hypotenuse. So, oh, there we go, I fixed it. Okay. What did I call it? Just going slow. Or will be. Okay, so then I'm going to multiply by b, divide by cosine of 62. And b equals 4 divided by cosine of 62. I did this because, again, this is a practice problem, so I did it quickly. 8.5. Then I'm also going to do the cosine of 28 now to get this angle here is a over 8.5. Now see, this one's a little bit easier because all I have to do is multiply by 8.5 to get my side. That equals 7.505. And now I have all of my pieces. Okay, so this is an interesting problem.